We're going to be starting this in just a minute. Hello. Hello. We're going to get back to work on this thing. We got more stuff to do. So, just going to make sure everything's rolling along all right with the twitches. And then we will get back to it. So one of the things we need to do here is we need to figure out like how we're going to calculate the bounds of our objects. And I think our physics objects have got the right stuff on them. I just got to go look through them and run through the geometry and then calculate the bounds based off of that. Alright, looks like the stream's up. And of course, I don't really expect anybody to be online at 3:30 in the morning here on the West Coast, but that's fine. We're gonna keep working anyway. Yeah. So we need to go through these things. I think the paper physics components have, yeah, we've got this body setup on it. So I think I need to call get body setup on the components, and then we have this U body setup. And I think the body setup has. Let's go to body setup.h. Yeah, I think we've got this aggregate geometry here. So I think we need like geo. We need to get that. And we're going to need to include the physics stuff for that. I think I included it. Does this still have the geo stuff? Or do we remove that? I think I removed it. I actually had some of this code written earlier. I'm going to look it up in Perforce real quick and see if I maybe... There we go. Because I had actually gone through and done a bit of this. So what I'm going to do is I'm going to make a physics utils function. And we had like been getting this corrected center for the primitive object, and that was wrong. But what we do need is to be able to get the bounding box for one of these geo pieces, and that's so we're going to do like get bounding box for component, because we were trying to get like that from the primitive component in Unreal, and I just was not seeing it actually work properly. So we're going to get the corrected, we're going to get the bounding box. And we're going to return an F box, because that's what we need. So let's see, if the component is null and other stuff is null, we're just going to return an F box. Otherwise, we're going to make an F box and return that. And whatever, like, if people are offended I keep referring to these as F boxes, well, they are F boxes, so too bad. Alright, so I rotate vectors, get collision maps for types, and we just need a get bounding box here. And it will also be a static method. Anyway, hello everybody watching. How's everybody's day going? We're not playing games at the moment. We're doing some C++ development for Dashkin and Unreal 4. So It's a creative stream today. That's what I do otherwise. So if actors null, yeah, we're gonna have to return the box as well. Why don't we just do that? Alright, so we're going to get the transformation, and basically what I think we're going to have to do is we're going to take these body setups in this geometry. Yeah, Adam, you need a grounded base, and your base is gone. Well, do your best. Do your best. So what we're going to do is we're going to go through all the boxes, convex elements, and sphere elements. And actually, I'm going to look up this aggregate geo real quick and see what's actually on it. I think this aggregate geometry is probably in here. Aggregate geometry.h. It's got spheres, boxes, spill or sifle elements, convex elements. And oh, there's actually a calc AABB right here given the transform of this thing. Well, hell, that makes it a lot easier than I thought. So, shit. That's what you get for reading documentation and code, isn't it? And we got a transform right here. So all we have to do is... Thank you for the follow, Milklows. How are you doing today? Hopefully quite well. I'm doing well. So I'm spending my weekend working on some awesome games. So we didn't want to get rid of all this. We just wanted to get rid of the geo. So we're just going to return geo calc AABB on the transform. And well, that was a lot easier than I thought. I'd have to go do something else is what I was thinking. So we want to go through all of these different components here, and we just want to add. Just want to grab them and get those boxes. So F box, C box for current box is going to be this guy. Get bounding box for components. Pass in the component. And that component has an actor, and that actor has a transform, and that is what we will be using. So I need to, basically our objects have a list of components on them, and we want like a bounding box that encompasses all of those things. So we're going to do like our box.min. Now let's actually undo a little bit of this work, and I think this function used to have a few things in it, which we want just to not have to copy paste all over again. Yeah, which is this stuff. Because I was trying to use Unreal's stuff to begin with, but it wasn't working, so sad days for everybody involved. So the max is set to the min is set to the max, and we're going to go through every single component here, grab the box off of that, and just do, like if cbox.x is less than box.min.x, then box.min.x equals cbox.min.x. Nothing too complicated. And hopefully this one actually works, unlike that frickin' navigation thing for Unreal, which wasn't doing anything. Hopefully their calc AABB for their geometries is actually working, because we've had some problems here where Unreal says, oh, this totally does what it's supposed to, and then we've had some surprises where it doesn't. It doesn't, and then we get angry. When we get angry, we take it out on Adam, and that's never good. Morning, Ploddington. So that should give us our bounding boxes. So maybe we should remove the comment that this function doesn't work anymore. Self-fulfilling. Only the finest. Yeah, can everybody hear everything all right on the stream? Music not too loud, all that, voice working. Anything that doesn't work, yeah. Like I burned my toast this morning. I was like, Adam, why are you breaking my toaster from Australia? This is just unacceptable. I didn't burn my toast this morning. I lied. I made that up. But Adam can still. He's at fault for making me lie. Blame the artist. I actually referred to I was playing Battle Brothers the other day, and I had this one archer guy who he kept fucking missing everything. So I was like, man, this damn artist right here. I was like, oh shit, slipped up there, wrong stream. That's like if you get into a really bad argument with a girlfriend or something, and then you call them mom. You're like, well, okay, mom, jeez, and then but it wasn't on purpose. You're just like, oh shit. That's when you know things are bad. Artist, archer, both are useless. I mean, you're not wrong. All right, let's just double check our math here. And what we're doing is we are looking for our box bounds. So this is what it's saying right now in the log. It's saying the box bounds are -5, -79, -51, 71, and 0 for the max. So obviously, this is, well, let's double check. So for fat sack, these box bounds aren't awful. So I'm gonna throw that down there real quick. But basically, fat sacks, we can actually go look at him. This is fat sack in all of his sacky glory. But basically, you can see this is what he looks like. He's got this box here, and this axis is the z-axis, and this axis is the y-axis. So this x-axis of 5 to -5 just doesn't matter. And what does matter are the other chunks here, which are -79 to 71. So it means that he's a little bit over to the left. He's not totally centered. But that's the y, and yeah, we'd expect that to be about that wide. And from -51 to 0, so that looks like a -51, and that looks like a 0, so that looks correct. The only problem is the bounding box is not taking into account the transform of the actor that it's on. So the bounding box that I need is not the bounding box in object space. I need the bounding box in world space. So I'm going to do get bounding box in world. Yeah, for component. You can get bounding box for component there. And we're going to make sure to, because getting it just a normal bounding box is actually something that we probably want. So we're going to call, oh yeah, I guess we can also clean up some of this stuff where we're not doing anything. So the f box is going to equal this guy, and we're going to return box, but basically we're going to do our, oh wait, what the hell? I set the frickin' translation to the 0 vector, so this is my fault. So actually, yeah, we just, that's all we need to do. All right, this is just me being stupid and not. And we also need get bounding box for component on this one because that calc height is wrong. XX min Y. Looks about right. Yeah, Unreal has its stuff kind of set up how it has its stuff set up. So we're not trying to fight Unreal in what it's doing, and that's kind of one of the things when you're working with an engine. It's usually best to adopt the engine that you're working in's kind of what it likes to do. Um, Otherwise, you end up like you change one thing and then you have to change another thing and then blah 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 down the line. So we're trying to do things the Unreal way, and the Unreal way is Z and Y and then X. Get bounding box or component. Well, that's totally what we changed that name to. Did we not? Why was depth by default? Well, we didn't change anything with 2D and Unreal. We kind of started with the 3D character project though, so that's probably why it's a little different. Just one of those things. Just one of those things. And the 2D stuff really isn't supported very much in Unreal as far as I've seen. Like the paper 2D stuff, like I think they're even like not continuing them. Get bounding box for component. Well, yeah, you gotta frickin' pass in the bounding box for the component, and you also have to throw this on the front. So let's go make sure we actually got the correct bounding boxes for our critter. We should be somewhere around negative 26,000 for our location, for our min and max for these things. That's what we're looking for. And if you guys have any questions or anything you want me to talk about or anything like that, feel free to just shout it out in chat, and we'll talk about it. Excuse me. Got the hiccups. What's going on here? Alright, we have struck an object with a raycast. What I care about, the box bounds are negative 5, 26,557. Maximum is correct. The maximum value is set to 0, though. What is going on with this? That should not be 0. So our Y value is getting set to something screwed up. That's what it looks like. Why would that be? Why would that be? And that is here. So if the C box max Y is greater than box max Y, then box max Y is set to C box max Y. Box max Y is set to the minimum. I mean, that doesn't look wrong. Slate! Why you crash on me? You've rotated the whole project. Oh god, no. Well, we didn't rotate it. Somebody else must have rotated it for us. I basically just, there's the 2D like the 3D platformer sample project is what we used as the starter. So if anybody changed the coordinates for the axes, it was them. But I'm not too worried about it, actually. Our height is not 26,000, but, well, that's fine with me. And yeah, it looks like the Y is all sorts of screwed up, so let's take a look at it. Yeah, it looks like the min and max for the inner boxes are set properly. The max Y is still jacked up. Why is that? In-game X is depth, and the boxes on the sprite are, yeah, they're all rotated by negative 90 degrees, because if we don't rotate them, then they don't show up. Alright, so why is the max, like, if the box max Y is greater than our max Y, and our max Y is getting set to 0? Is that 0? Or is that something? Are the T numeric limits for floats actually getting set properly? No, you have a very good point. No, you are correct. We're rotating the sprites. We're not rotating the world, we're rotating the sprites. But you are absolutely correct. In the actual sprite itself, X is left and right. At least I'm pretty sure. I'm pretty sure that's what I did. I have to go look at the actual import code. But I'm going to go look at this T numeric limits real quick and see if it's actually setting. Yeah, there's a lowest, and then there's like a min. What the hell is the difference? What is lowest T numeric limits? Oh no, that's not causing the problem here. The problem here is that our I think our max Y is getting set to basically 0 when we're setting this numeric limits lowest. Because when we actually do like our box here, we're getting the right values for the box, but our max Y is getting set to basically 0 as opposed to, I mean, I guess maybe I'm supposed to use lowest instead of that. I've always been like seeing float min and float max. Yeah, min Y should be max here. That's true. The min should be the max should be, well, let's just try lowest. So we will see. Yeah, we basically, the last session here, we wrote a whole bunch of code to make FatSack roam around, and we are now testing that code to get all the bugs out of it. So max y is negative 25, and min y is negative 25.8. So yeah, it looks like lowest actually was what we needed to call. And let's check our bounds real quick here. So we have our box set up here. Looks like our bounding box is correct now. Oh, this is just a simple, like, we're just finding the minimum and maximum for a thing. And basically me not understanding that, like, min was not returning minimum. It was, you know, the minimum value for a float. It was returning 0. It's like, what? I always thought that min returned the minimum value for the thing, not 0. Alright, so yeah, so here we are, and we got to start doing like math and stuff like that. So we need to print out our things real quick. So this will be step 2 start, direction, and distance. I should probably show people some pictures real quick as to what we're actually doing. So basically what we're doing right now is we got FatSack and he's running through the world, and in this picture FatSack is the box. So he's running around, and right now we've got it so he can basically run on a flat plane. He can run on a plane that looks like this. He can run on stuff that looks like this. And we're getting it so he can run on stuff that looks like this. So he can run to the right, and then like he'll actually like get on top of the next platform. And there's a lot of little things that come into play with this, like, well, what if the ground looks like this? What if the ground, you know, looks like this? What if the ground looks like this? Like you've got, you know, a place where you should be able to step up into and all that stuff. And so what we're doing right now is, I think this picture shows it best, is we basically got like FatSack, and he runs into the wall, so he's like right here. So he's right here, and we've got this like normal to the point of collision, and we're taking this bottom right corner when he's trying to move to the right, and we're moving it up to here. Well, not up to all the way there. We're moving it to here. Basically, we are going to cast FatSack like this. Are we actually casting straight down? Our location is step direction. We are ray tracing. Well, those are the wrong numbers. The start is step 2 start plus that we are subtracting the perpendicular normal. So we're actually kind of casting it like this. So the idea is this is going to form a plane, and we move FatSack's bottom right hand corner to here, and then we cast him up here like this, and then we cast him down. He's going to actually be able to mantle over this thing, and it's not going to slow him down. He's going to be able to mantle up into something that is his height. And we've also got code in here to iteratively check, so maybe there's, maybe he can't reach this little first place, but maybe there's like another place above that where he can mantle up into. because we got some crazy geometry. So it should still work in a lot of situations here where we're basically iterating based on the height of fat sack. We are going to a certain height and casting some rays over basically in order to find a way to get him up there. And this is going to basically just take any basic stuff and make it work. This is in frame stepping up. This is not multi-frame stepping up where like if you were on like a section of stairs and you were going up the stairs, for Fat Sack here, he would just like teleport to the top of the next staircase. So if he was running, he'd be running full speed and just like you go here and then boom, he's right here, and then boom, he's right here, and then up here and up here. He is not like running up the steps nicely stepping. If we were going to be making steps that we wanted somebody running up, the steps would probably look like this, but we'd have like some collision geometry that's actually a ramp or whatever and make it smooth. Or we would actually have like specific steps which are programmed in there, and then Fat Sack would be literally like stepping. We'd have like a specific animation for jumping up on top of the stuff. But it's a speed-based game, not a stair-stepping game. So it's more like Sonic. If Sonic doesn't run up and down stairs, he runs up and down ramps. So that's kind of what we're trying to do. Okay, so we're printing out step 2. We're going to print out step 3. Fat Sack staircase has a spiral. If Fat Sack has a spiral staircase, I advise Fat Sack to watch his step. Because I think he's going to take a tumble down those stairs. You know what I'm saying? So this will be sweep 1. And sweep 1 distance. So kind of how it goes is we're casting these rays in order to discover the path. And then based on discovering the path, we're going to then sweep the geometry through the correct path to figure out if Fat Sack can actually navigate that traversable space we've discovered. Or not. And then we'll move him. Because we have all the best plans. Yeah, let's also print out that settle location. Wait, what is this? Fat Sack's spine was broken in a terrible tumble. Did he fall or was he pushed? I think we're gonna have to round up a few of the usual suspects in Brackenwood and figure this crime out. We know you're lying, Bitey. We know you did it. I think it's just Fat Sack trying to collect on the insurance money. And then he's gonna retire to the Bahamas with his like awesome big navigators, his aviator shades, and just gonna be Fat Sack sitting there getting drunk all day. That's the reason why Fat Sacks are all fat. It's because they're just drunks. Oh no, we've crashed. That's because we're referencing something that does not have a hit in it. Step 1 sweep hits. We're just going to double check our hits arrays. That's part of the reason why we went ahead and named all these things very specifically, is just to catch any boneheaded errors here where I'm indexing into the wrong hits array. You know, because I make those errors way too often around here. So, there we go. And I think Adam would be streaming. Adam is Cluade in chat there. He's my partner in working on this project. He would be streaming, but he's working on super secret stuff like story that he can't do that on stream. So you're stuck with me for a little bit today. Why? What is going on here? Oh, geez, yeah, I didn't copy paste everything. I just copy pasted the thing that I saw. All right, I think we got that fixed. I'll try it again. Cell shaded backgrounds. Oh man. Well, that guy is over in Longview, Washington. Maybe we should go talk to him. Go take him out for a beer and then steal all of his code. No, more of just say hello. We probably do need to go talk to other people and steal some of their thoughts. Share some of our tech. Do some awesome things. Alright, well, I'm looking at Fat Zackoff on the other screen. We have a few issues, as expected. Let's just do one max mantle iteration attempt, and then we'll walk through the code and see what happens. Well, I'll write it down. Fat Sack is the main character for at least today. Basically, Bitey has a whole bunch of states and all the rest, and Fat Sack doesn't. So I'm using Fat Sack as a test character just for the current bit. Since he's simple, he's just a box. I don't have to deal with a whole bunch of stuff to make him work. Alright, so we're attempting to mantle. And our height is 150. Our height is 151. Our height is definitely not 151. Our width is 151. Alright, so that's wrong. Oh yeah, because I'm using the y coordinate. It should be max z. And min z. That's probably the biggest surprise for everybody when they learn about Dashkin is it's actually Dashkin, The Adventures of Fat Sack. because we just need more fat sacks in our lives. It's something that happens. Fat skin. Ugh. Ugh. It'll be fat sacks racing to McDonald's. Alright, our height is 48 as we expect it to be. So we're going to go through our attempts. The step 1 start is... I don't even know what kind of game this is. I don't know what any of this is. This is going to be like a speed-based platforming game where you're running around as Bitey, the super fast spirit of the wilds sort of dude. So our step 1 start is -25,658, 557. Alright. Our direction for step 1 is -5, so it's just 1 in the up direction pretty much. Our direction is kind of 0, 1. But that's a very small negative y. No, it's not -1. It's a positive 1. So it's very small y. Let's see, why is that? Because our normal to the collision was -1 and then a very small negative z, which is correct. I'm looking over at him and it's kind of a little chunk. So that looks like the correct step direction. We're supposed to be stepping from basically the bottom right corner of the minimum z, and the velocity is positive. So I would have expected us to rotate the vector perpendicular to the motion from this -1 to a +1. So we're supposed to start and then cast a ray. The distance is 48, which is correct. Okay, so distance of 48. That's right. We are going to do a ray trace in that direction. We didn't hit anything. Okay, good. So we didn't hit anything with step 1. Step 2 start should be step 1 start plus step 1 direction. So step 2 direction is negative normal to collision. So that's going to be a negative normal to collision. That's going to be a +1 and a positive z. So it's going to be a little bit up and mostly to the right, which is correct. 2000, yes. Adam is working on Brackenwood for ever. Step 3 is step 2 start plus step 2 distance times step 2 direction. So step 3 start is -25, 658, 605, 75. So it's looks like about 40 or 50 above, which is 48, which is our correct. So that's the right start. The direction of step 3 is supposed to be negative perpendicular to collision, so it's going to be basically straight down, and the distance is going to be down. So ray tracer. Alright, so what's it going to be? The impact point is this, and the impact normal is the impact normal is negative something and then 9961. Okay, so the sweep 1 start is going to be the sweep 1 position X, which is new position. That's our current position. Step 1 start is the corner, so we're sweeping our guy. Six months? No, we haven't been working on this for 6 months, have we? We've been working on this since January 2nd. So let's see, we should not hit, so we didn't hit anything. And our position for sweep 2 is going to be new position plus sweep 1 distance times perpendicular of normal. So we're moving up. Sweep 2 distance vector is going to be, what is the projection vector? Yeah, it's not, let me see. What is sweep 2 distance is nearly 0. So we're not going too far. Alright, so we didn't hit anything in sweep 2, which is off and to the right. So it's going to be new position plus, yeah, what is the settle start location then? And then 608. Negative, so we went backwards in the y direction? We should have gone, so step 1 start. Well, let's see, what was our position to start with, our new position? Thanks for hosting, Karakan. you count November? Alright. So the settle location is there, but I need to see what this new position is. So what do we got right now? New position is 7629 608. So it looks like we didn't move at all, is what's going on here. Well, okay then. So what we're going to do is we're going to add a little bit more debugging to this thing. Any progress? Oh, well, we fixed some of the calculations for the box width and heights and all that stuff. And we're at the point now where we're verifying our vector math, and it looks like we aren't moving anywhere. So looks like we found a place to step up, and then we're not actually stepping up to that place. Kind of like we did all these ray casts for moving. We're like, oh, cool, we'll just go here and then over, and then like we end up in the same place. So there's a couple things that might be going on there. So what we're actually going to do is, I think we've been using Tiny Float. Yeah, we're going to make another float here called Mantle Float. And we're going to make it really big. So we can, we're going to blow up our math so that we can see absolutely everything that's going on here. And we're going to use Mantle Float for all the things. So step 2 distance is going to be Mantle Float. So we're looking for instances of Tiny Float in here. So yeah, sweep 1 is going to be Mantle Float, and Mantle Float again. Also, yes, hello. Back after a delicious dinner of rice and tomatoes mixed together. Spanish rice. Good stuff. Also threw in a bunch of hot sauce, which makes it even better. And I think what I need to do is, like, we got this physics trace tag. I can change the trace tag so I can only trace like this specific type of thing. And when you do traces in Unreal, you can see all the geometry that I was tracing around, which is actually pretty cool. So if we get completely befuddled in numbers, we can always just spend 30 minutes and write a whole bunch of stuff to help us see our math, instead of just write our math down and then wonder why it's wrong. But we're going to start from misery because that's where we belong. Oh, there we are. Oh no, he's in the air now. Alright, so where is that camera? There it is. We haven't done the air collision just yet. Yes, and he got over it. He mantled. Fat Sack is now a professional. Oh my, that is... I do not know how to move things around super well in Unreal 4's editor. So I'm just kind of winging it. Basically, wherever I put this camera, Fat Sack spawns where the camera is and immediately gets chunked onto the floor. So that's kind of what I'm doing there, is by changing where this camera is, I'm changing where Fat Sack lives. Alright, so this is our trace. And as you can see, we're also passing our... Yeah, we were able to like mantle over stuff nicely. Bam, 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 bam. That's excellent. That's what we want to see. Just perfectly moving real smooth over these objects. Yeah, just That's what we want to see. Just moving straight up and over. And moving along these seams, these two objects right next to each other, we're actually hitting. Because we're moving, how we're moving Fat Sack right now is, when he comes across a joint like this, he's actually moving normal to the surface he's on. So when he's moving towards this, he's actually going to hit right here. And then he's going to move again, and he's going to move up the slope. So him going over these like little seams here without a problem is, that's actually what we've been working on right now, which is great. And so, and we can't run into this wall. Why not? Well, we'll investigate that. So why don't we set up a few little things here for Fat Sack, a few more little test things just to make sure we got this mantling stuff properly done. Oh, jeez. What have I done? Where's the world? Okay, yeah. We're going to undo. Okay. We lost it, guys. We lost the world. It's probably a much easier way to do this. Like, I could probably just manually enter the coordinate. Boy, where the hell did the camera go? Why has the camera disappeared? Why can't I see the camera? No. Kill it. I screwed it up. Yeah, I'm surprised it actually worked. Like, we drew some pictures, we wrote a whole bunch of bullshit, and then we fixed a few little things, and then Fat Sack's running around. What? This looked like I actually planned this. Alright, we're actually going to move right over to here. Alright. So what we kind of want to do here is we want to make a few little things that are going to cause some problems for us. So let's go ahead and make something that looks like this. Let's make a little sandwich, a little place here for Fat Sack to go, and we're gonna see if our math freaks the hell out or doesn't. And this one's pretty good. Yeah, this is good. I like this idea here. We're actually gonna do it like this. So we're gonna run into that wall there. I'm gonna see what happens. Well, this is not what's supposed to happen. We are supposed to immediately pop up on top of this thing. So let's figure out exactly what's going on. Actually, yeah, that's why we're not going. I changed the iteration for Fat Sack to only once for the mantling. So that's probably what's going on there. So let's go ahead and save the level and close that. And change our iterations back to 10. And Fat Sack will probably be able to climb this thing. The Fat Sack sandwich, I would buy that. Like, I would get a Fat Sack sandwich and eat it